Hello everyone, welcome to another Python tutorial series. And in this video, it is going to be part 3, the last episode of the AI plays Flappy Bird tutorial series, and I hope you like it. So we're going to deploy the AI and let it play the game. So before we start, I want to go fix a typo in my previous video. So if we go to our bird class, which is right here, and we scroll down a little bit into the find nearest pipes function, and into this else statement, here, this should be nearest pipe top. So quickly fix that typo, and we'll move on. So what we have is a config file, a config text file for the neat Python simulation, and I've already created one in my working directory. So the neat config file is a text file that contains all the details of how the network will be trained. You can specify all the essentials in here. So I'm not going to go into the details of all the parameters in this file, and if you like, you can go to the neat Python official website for more information, and it has a detailed description of each parameter in the config file. I do want to highlight some parameters that are essential or unique to this game. So if we go to line 3, which is right here, the fitness threshold is the number that we will decide, and once the fitness exceeds this number, then we'll terminate the program. Next, if we look at line 4, here's the population size, or the pop size, and this defines the number of birds in each generation. So here we're setting it equal to 30. Now if we scroll down to line 48, which is num inputs, this is going to be the number of input nodes, and the network receives inputs through nodes. So in this game, there are going to be 3 parameters, which are going to be the 3 distances we calculated in our previous video. So that's why we have 3 inputs. Now if we go one line under, we have number of outputs, and this is going to be the number of output nodes. So the network delivers outputs through output nodes, and the 2 outputs in this game is going to be jump or fall under gravity for the birds. So the neural network, or AI, will determine whether the bird should jump or drop under the influence of gravity, based on the 3 distances that we calculated, and it will train itself to get better at the game. So when AI is implemented, the game will not quit when the bird is dead, and instead it will train itself and evolve to the next generation. So we need to get rid of a piece of code. So if we go back into our code, and we go into our game loop, what we could do is remove this if statement. If bird dead, pygame.quit. So I can highlight and delete that. So now let's find the nearest pipes to the right of the bird by calling the find nearest pipes method, and this includes both the top and bottom pipes. So right underneath, I'll have nearest pipes equal to bird dot find nearest pipes, and I'll pass in the parameter of pipe list. Next, we will find the nearest pipes when the pipes appear in the window and to the right of the bird. In this case, we'll need to calculate 3 distances. Otherwise, we'll assign the width of the window to the distance list, and wait until the pipes appear in the window. So essentially, if nearest pipes index 0, so if it has a value at the 0th index, we'll set distances equal to bird dot get distances. We'll pass in nearest pipes index 0 and nearest pipes index 1. Else, we'll set distances equal to the window width times 3. So next we're going to load the config file and try to run the file. So let's get rid of this line first, which is essentially just the game loop. And so now we can replace the line that we just deleted. So I have neat config equal to neat config neat default genome neat default reproduction need dot, or I'll make this new line, need dot species set need dot default stagnation and config.txt. So we'll set the population equal to neat.population, and we'll pass in the neat config as the parameter. We'll set stats equal to neat.statistics reporter population dot add reporter. We'll pass in the stats, and here this will give us some statistics, like a statistics report for each generation. And then population dot run, we'll pass in the game loop with parameter 50. So this will call the game loop function to run the game, and 50 is going to be the maximum number of generations allowed for the AI game. So in the AI, game loop is going to be the fitness function, which computes a single real number indicating the quality of an individual genome. And the better ability to solve the problem means a higher score. So in this fitness function, we'll need to add two parameters. The fitness function will evaluate each of all the genomes. So if we go into the game loop, we could pass in genomes, the config. Instead of creating a new bird like this, so bird is equal to bird, I'll remove that. And instead I'll have a birds list, because we're going to have a lot of birds in each generation. And we'll also need to create a generation variable and initialize it as 0. And this will help keep track of which generation that we're currently on. So we'll set gen equal to 0 first. So if we go back to the game loop, I'll set the global gen variable, and then each time the game loop runs, I'll increase the generation by 1. So we'll also create another toList in the fitness function, which is going to be nets is 0, GE is 0. So nets will be used to keep track of the neural network that controls the movement of each bird, and GE will be used to track the genomes so that the fitness can be changed based on the scores the birds get. So now we'll loop through the genomes to get the nets, birds, and GE values, and set the initial fitness value to be 0 for the bird. So if we go down, for underscore genome and genomes, net will be equal to neat.end.feed forward network.create genome and config. Genome.fitness will set it equal to 0. And we'll append net into the nets list. We'll create a new bird. So birds.append bird, and g.append genome. So we'll also remove the manually make the bird jump part, because this will be handled by the AI. So here we're getting the key state, and then we're checking if space is pressed. So what I'll do is highlight and then remove that. And let's create 2 more variables to keep track of the number of birds alive and the max score of any alive bird gets. So inside this while true loop, after we iterate through each pipe, I'm going to have a variable called alive birds, set it equal to 0 first, and also a max score, and set that equal to 0. And because we have more than one bird now, we will use a for loop to loop through the bird. So instead of doing this just for a single bird, I'm going to write a for loop. So for I, bird, and enumerate birds, I'm going to check if not bird dead. So basically if the bird is alive, then I want to do all this stuff. So I'll highlight this and indent it twice so that's inside this if statement. So for every single bird inside our birds lists, I want to check as long as the bird's still alive or not dead, then I want to basically allow gravity to work. So we also want to calculate how many birds are alive at any given moment, as well as the maximum score. So after we increase the bird score, I'm going to increase alive birds by 1, which is the variable I just created. And I'm going to set the max score equal to the max value between the max score or the bird.score. So we then want to increase the fitness score of a bird based on the score the bird gets. And this will make the AI favor the birds that have more scores or stay alive longer in this game. So G index I fitness plus equal to bird.score. So now we'll feed the inputs and activate the neural network. So right after this else statement, I'll set the output equal to nets index I activate with a parameter of distances. So the output is a list that holds the output values from the neural network. So then the network will determine when the bird jumps. So max is equal to output dot index max output. We want to check if max end is equal to 0. Then bird dot bird rect dot center y minus equal to jump. So what this does is to find the index of the maximum value in the output list, and if the index is 0, then the bird is going to jump. So if all the birds have died, the neural network will exit the game loop function with the current network generation and essentially move on to the next generation. So outside of this if statement, we want to check if alive birds is equal to 0, then I just want to do is return. So if there are no birds active, then I'll just return out of the loop. And then I'll move on to the next generation. So now let's modify the text message showing onto the scoreboard. So if I check the message, I set it equal to score and then the bird score. So what I'll do is I'll quickly change this. I'll set this to generation. And instead of the bird score, I'll do the generation and then birds alive birds, and the score int max score, like that. And instead, I'll window output this onto 4020 instead of 020. Now lastly, we can also change the font. So if I go to the font, I scroll up to where I declared the font. Let's see. Font is equal to pygame.font.sys font. And what I'll change this to, I'll change it to Comic Sans. So that's basically finished. Our neural network setup. And if we run this, we should see the AI learns to play the game itself. So if I save and run this, let's see. Name distances is not defined. So if I go to line 77, distances index 1 is equal to bird rect dot top left minus bird pipe dot bottom right. This should just be distance. Yes, this should just be distance. So now if I save and run this, this should be distance as well. So now we see that the bird, or the AI, is training itself. Right now we're in generation 2. We have 3 birds alive. And if we keep this going a little longer, we may see, well actually it looks like the AI has already gotten it perfectly. We have 2 birds alive, and they're already on 14 points. So on top of the game window, we see the information of the neural generation, or the network generation. We have 2 birds alive, 2 generations, and right now both the AIs are doing really well and have a score of 24, 25. It's increasing gradually. So it seems like this AI has already done it perfectly, so I'm going to quickly close it. And many people would like to show the lines that connect the player and the obstacles. So basically the lines that we use to measure the distances used as the input for the network. And we can also do that. So we'll create a drawing method in the bird class. So if we go to bird class, we'll create a new method, define draw lines, self, top pipe, and bottom pipe. So we'll do pygame.draw.line. We'll add it to the window. We'll set the color to red. And we'll have the first parameter self.birdRect.midRight. And it'll connect to the top pipe mid bottom, and we'll have the line thickness or line width as 5. And what I'll do is copy paste this. So this first one is for connecting the bird to the top pipe, and here I'll connect the bird to the bottom pipe. Instead of mid bottom, I'll connect it to mid top. So then we'll call the drawing method. If we go to our game loop, inside of this if statement, so if nearest pipes index 0, then I'm going to call bird.draw lines, we'll call the nearest pipes index 0, and nearest pipes index 1 as the parameters. So now if I save and run this, now we see that we have the red lines, and we see that the AI is still learning. So we have 2 birds alive in the second generation, and they have a score of 9, 10, and they'll keep gradually learning. So this is the end of this video, and also the end of this series. If you have any comments, please put them below in the comment section. If you have not subscribed to the channel, please hit the subscribe button below. Thank you for watching, and I'll see you guys next time.